Hi, my name is Saeid. I'm with Prep 101. In this primer, we will talk about inverse functions. This is one of the topics that is discussed at the beginning of Math 186 at U of T. You need to be familiar with inverse functions to grasp fully the idea of inverse trigonometric functions. Okay?
When it comes to inverse functions, first we have to make sure that the function is invertible. This means the function must be one-to-one. Remember that in some cases, the original function is not one-to-one, such as trigonometric functions. But when we want to find the inverse function, we actually restrict their domain to make it one-to-one. This is actually explained in another premiere. So the inverse of a function is another function such that f inverse of f and f of f inverse is equal to x. So think about function that takes you from x to f of x, or takes you from x to y. So this is what f of x does. And think about inverse as a function that does the opposite. So it takes you from y to x. So that's f inverse of x. Now if you start from here, you go to y, and then you come back. That means if you apply f inverse on f, then you go back to x. So this is why you're going to get an x here. There are three types of questions that you get when it comes to inverse functions. These are the main three types of questions. First, they ask you whether the function is invertible. For that, you have different ways. The easiest way, if you have the graph of the function, is to use the horizontal line test. So you draw a horizontal line, and then you will see if your graph is intersected at only one point or at more than one point. If the horizontal line crosses the graph at more than one point, something like this, then this function is not one-to-one, because as you see, the horizontal line crosses the graph at 3 points. Whereas in this case, that I have a function like this, if I draw a horizontal line, no matter where I keep it, it only crosses the graph at 1 point. So this means this function is one-to-one, but this function is not. Now let's do an example on this. Which of the following functions is an invertible function? Well, we want to do the horizontal line test again. So we draw a horizontal line, and you see that it crosses this graph at more than 1 point. So the function is not one-to-one. Same thing with this function. It crosses the graph at 3 points actually. Same thing with this function. It crosses the graph at 2 points, and in some cases, if I bring this down, if I just draw it down here, you see that it crosses the graph at 3 points. The next one is also not one-to-one because it crosses the graph at 4 points in some cases. The next one, it crosses the graph at 2 points in this case. I mean, this one, and even this one, they're not even a function because they failed the vertical line test. The last one, however, if I draw a horizontal line, no matter where I draw it, it always crosses the graph at 1 point. So this one is a one-to-one function. So that's the first type of question. The next one is they ask you to actually find the inverse of a function. So they give you the original function, and then they ask you to find f inverse, such as what you see in this example. So the steps are very simple. If they give you a function and ask you for inverse, you interchange x and y, you solve the equation for the resulting y. So let's do that in this question. F of x is equal to x over 1 plus x, and I want to make sure that it is. So first I need to make sure that the function is invertible. And here I want to show you how you can use the method that was mentioned here to show that a function is one-to-one. So we don't have the graph. This is why to show that a function is one-to-one, we have to use this method. So the method says if f of x1 equals f of x2, you should be able to conclude that x1 equals x2. Let's give it a try. So checking 1 to 1. So if f of x1 equals f of x2, which in this case means x1 over 1 plus x1 equals x2 over 1 plus x2, I should be able to conclude that x1 equals x2 by doing a little bit of algebra. In this case, I'm going to cross multiply this equation, and that gives me x1 times 1 plus x2 equals x2 1 plus x1. And then I'm going to distribute this. That gives me x1 plus x1 x2, distribute this side, x2 plus x1 x2. So here you see that I can subtract x1 x2 from both sides, or I can cancel them. What this implies is that x1 equals x2. So this one means the function is 1 to 1, and I'm now able to find f inverse. In many questions, when they ask you whether to find the inverse of a function, you have to check whether the function is 1 to 1 first. So in order to find f inverse, this is actually y equals x1 plus x. The first thing that we do, we actually switch x and y. This gives me x equals y 1 plus y. Some textbooks, they start solving for x and then later on they switch x and y, but that should result in the same answer. So now I try to solve for y in this case. I cross multiply, that gives me x 1 plus y equals y. Then I'm going to multiply and I'm going to distribute this x, that gives me x plus xy equals y. Then I try to bring all the y values to one side. So y minus xy equals x. I'm going to factor out y, 1 minus x equals x. And if I solve for y, that gives me x, 1 minus x. So technically, what I just found is f inverse of x. So f inverse of x is x over 1 minus x. So that's how you find inverse of a function. You need to do some algebraic operations in order to solve for y when you switch x and y. This is after you check that the function is 1 to 1. And then the last type of question is when they ask you to evaluate f inverse at a point. Now remember that if f of a is equal to b, f inverse of b is equal to a. When they give you this type of question, such as what you see in this example, usually finding the inverse is not easy. Sometimes it is impossible. So they ask you to find f inverse at 3 given that f of x is this. Well, in this case, it is almost impossible to solve for f inverse, simply because if I switch x and y here, I'm not able to solve for x, given the expression of exponential and algebraic expression that I have here. However, remember this one. So this side is given to me, technically, and I'm actually looking for a, but that also means that I can write this side. So I'm looking for a, let's call this a. I don't know a, but I know that f of that is equal to b. b in this case is 3. So that means a is some number that if I substitute into the equation, that gives me 3. So that gives me f of a means e to the power of a plus 2a plus 2 is equal to 3. This gives me e to the a plus 2a. I can bring this 2 to the other side. That gives me minus 1. So this is now a bit of trial and error that you have to do. So usually when they give you this type of question, there are simple numbers that you would substitute or some integers that you substitute and it gives you the answer. So you need a bit of trial and error. And don't try to solve for a, because there's a reason you couldn't solve for f inverse at first place. You're not able to solve for a algebraically. So it's trial and error. So after a bit of trial and error, you can easily see in order to get rid of that exponential function, you need to put a power of 0. And if you put a power of 0, then you would get e to the power of 0, which is 1, plus 2 to the power of 0, 2 times 0, which is 0. That equals, sorry, this must be plus 1. This is going to give you 1. So 1 equals 1. And this simply means a equals 0 is actually the answer that we were looking for. And that means f inverse of 3 is equal to 0. These are the 3 types of questions that you can potentially get when it comes to inverse functions.
I hope that you found this useful. If so, check out more foundations of first year calculus in the playlist. Also, make sure to join our Facebook Study Hub for this course. You can find the link in the description box below. Finally, I hope to see you at my prep session. I will show you how to solve midterm and exam problems and how to do that with confidence and how to ace your midterm and exam. Remember that many prep sessions for midterms are free. Visit prep101.com for more details. Thank you for watching.